We're going to begin chapter 16 by looking at a reaction with an ester and 2 moles of Grignard reagent. You're going to be making alcohols. So chapter 16 deals with alcohols, diols, and thiols. We're going to focus primarily on alcohols and diols. The first reaction, you have an ester. So here's our basic ester. It's going to react with 2 moles of the Grignard reagent, where the alkyl groups on the Grignard reagent are the same. And then, of course, you're going to use an acidic environment to provide you with the hydrogen that's going to break the carbonyl-carbon like we've done in some of the reactions in the past. So the first thing that will happen is we'll break this bond. Your hydrogen is going to come up here and link up to the carbonyl-carbon, so that oxygen of the carbonyl-carbon. And then the 2 alkyl groups off of the Grignard reagent are going to attach to the carbonyl-carbon. This is going to create your first alcohol, which will be a tertiary alcohol. Your other alcohol is going to come from the back half or the second part of the ester, where you've got your O and alkyl group here. So that R group is going to pick up a hydrogen and form a primary alcohol. So when you take an ester, react it with 2 moles of the Grignard reagents in an acidic environment, you're going to make 2 products, a tertiary alcohol and a primary alcohol. Now, if you're looking at the PowerPoint for our chapter 16, the first thing talks about our sources of alcohol, and it gets into a little more detail than necessary, so I'm just going to kind of go over some general things to be sure you look at, but you have the PowerPoint so you can read the remaining things if you wish. But these are just some of the basic alcohols that we typically look at. So methanol is referred to as wood alcohol. The reason it's called wood alcohol is because it's a byproduct of the production of charcoal when wood is burned. One thing about methanol is certain quantities of it. So if you have 30 milliliters or more consumed, it can be lethal. Smaller amounts can lead to blindness. So it's a cheaper form of getting alcohol, so some people would drink this just to get their alcohol fix. But as you can see, it's a very dangerous kind of a Russian roulette kind of thing. Your ethanol is referred to as grain alcohol. It typically forms through a fermentation process of vegetable matter. So just to give you some specifics, if you ferment barley, the ethanol that is produced there is used in beer manufacturing. And if grapes are going to be fermented, then that's typically used in the wine industry. So just for your information. Isopropyl alcohol is referred to as rubbing alcohol, and it's typically used as an antibacterial or sterilizing type of substance that's used for cleaning wounds and that kind of thing. So that's just some generic stuff on alcohols. So let's look at some sources of alcohols via reactions that we have done in the past. So we're just going to review some reactions real quick. So there are 4 basic reactions that we have done so far. Now the third one we really haven't looked at that much. We'll kind of go over it, but it's not a real common reaction. But these are reactions that we have done in the past that allow us to make alcohol. So the first one is the hydration of an alkene. So you'll take your alkene, you'll react it with your acid and water. So a diluted form of acid, basically. I think that's what we called it when we did it before. 50% alcohol, 50% sulfuric acid, 50% water, and you'll make your alcohol in that form. The second one is your hydroboration, oxidation of an alkene. So in this one, you're going to use either your diborane, your diglyme as your solvent, your oxidation step with your peroxide and your base, or you can use just your borane, your BH3, and your tetrahydrofuran. Now remember, this one is going to be antimarkovnikov, so it's going to go in the less stable position, or the carbon that has the most number of hydrogens, whereas the top one follows the Markovnikov's rule, so it's going to go on the carbon that has the fewest number of hydrogens. This one is also a syn addition for the hydroboration oxidation. Now the third one is the one we really haven't looked at. It's the hydrolysis of alkyl halide. If you're looking at this one, you're going to use some kind of a hydroxide group. So in this one, this example, we have a calcium hydroxide, water, and you're going to form your alcohol with your halide ion here. The last one we did in chapter 12, and this is where you're looking at, this is chapter 14, I guess, or 15. This is where you're looking at your Grignard reagent or your organolithium compound, reacting it with either an aldehyde or a ketone in the presence of diethyl ether and acid, and you'll make your alcohol. So it doesn't really matter which one of these you start with. If you use formaldehyde, which is your simplest aldehyde, you're going to make a primary alcohol. If you use any other aldehyde, you'll make a secondary alcohol. And if you use a ketone, you'll make a tertiary alcohol. So those are just kind of reviewing over the reactions that we've done already to make alcohols. In this chapter, we're going to look at some new ones. So these are the ones that we'll look at this point. The first one is a reduction of an aldehyde or a ketone. So you're basically going to reduce the carbonyl-carbon from the double bond to single bond OH group. So in this one, if you have an aldehyde, you're typically going to make a primary alcohol. If you have a ketone, you're going to make a secondary alcohol. If you want to make a tertiary alcohol, you can't use this method. We have to use something else. So for reductions of aldehydes and ketones, you can only make primary and secondary alcohols, depending on which one you start with. This reaction that we did is a hydrogenation with a metal catalyst. So remember, our metal catalysts are typically platinum, palladium, nickel, or ruthenium. So you can use these. These are typically used on the industrial scale, but you're going to, basically the hydrogen, one hydrogen from your hydrogen here is going to link up to the carbonyl-carbon to form a carbon-hydrogen bond. The other hydrogen is going to link up with the oxygen from the carbonyl-carbon to form your OH bond. And that's what's going to take place through these examples. So in this one, you have an aldehyde. So you can see you're going to get a primary alcohol. On this one, again, we have an aldehyde. So again, we get another primary alcohol. If you use a ketone, you're going to see that you're going to get a secondary alcohol. So here's just a more specific example of that. So the hydrogenation with a metal catalyst is one reaction that we can use to create our primary and secondary alcohols from aldehydes and ketones. Another thing we can use as reducing agents are metal hydrides. There's two forms of metal hydrides that we're going to look at. One is called sodium borohydride. It's given the symbol, or excuse me, the formula NaBH4. And also we have a lithium aluminum hydride, so that's lithium and aluminum with 4 hydrogens. These are used more on the laboratory scale, whereas the hydrogenation with the metal catalyst is used more on an industrial scale. If you use the sodium borohydride with the aldehyde, just like you did earlier, you're going to make a primary alcohol. If it's with a ketone, you make a secondary alcohol. You also need to use water, methanol, or ethanol in this reaction as well as solvents and necessary substances to provide your hydrogen. Your lithium aluminum hydride reacts violently with water, so we actually have to carry out this process in 2 steps. So you're going to either use a solvent of diethyl ether or tetrahydrofuran, and then you'll use your water. Like the Grignard reagent, you're going to react with the carbonyl carbon, but the difference between the Grignard reagent is the hydrogen source. The Grignard reagent was not the hydrogen source, whereas these metal hydrides are the hydrogen source. So let's look at an example. So if I start off with this compound, your meta-nitrobenzaldehyde, I'm going to use the sodium borohydride and methanol. The hydrogen that is going to link up to the carbonyl carbon is going to come from the borohydride ion. And the hydrogen that's going to come from, to make the OH group, is going to come from the methanol. So the borohydride provides the hydrogen to go link up to the carbonyl carbon. The methanol provides the hydrogen to make the OH group on the alcohol. Same thing here if you're looking at this one. Now this time we have a ketone. So the hydrogen from here is going to form the hydrogen here. The hydrogen from the ethanol is going to form the hydrogen on the OH group. And of course you're going to make a secondary alcohol here. If we look at using the lithium ammonium hydride, just remember that it is more reactive than the sodium borohydride, so we can't use water initially because it will react violently with it, so we have to do a 2-step process. So its solvent is going to be diethyl ether or the tetrahydrofuran. The aluminum hydride ion is going to provide the hydrogen that goes to the carbonyl carbon. The water is going to provide the hydrogen that goes to the OH group, just like the alcohol did for the sodium borohydride one. So in this particular case, if we start off with the aldehyde, we're going to use our lithium aluminum hydride, diethyl ether. That hydrogen is going to link up to this carbon, the carbonyl carbon. The water is going to provide the hydrogen to make the OH group. Since we started with the aldehyde, you're going to make a primary alcohol. Ketone, same thing. This provides the hydrogen for the carbonyl carbon. This provides the hydrogen for the OH group. Make a secondary alcohol. Now these are selective, so if you use either sodium borohydride or lithium aluminum hydride and you have other bonds, like here we have an alkene, so we have an alkene bond here, it's not going to affect the alkene bond, it only affects the carbonyl carbon bond. So you'll leave this one alone, and then this will be where the reaction takes place, and you'll get your OH group. Now if we want to prepare alcohols by reducing a carboxylic acid, we have to use the lithium aluminum hydride. The sodium borohydride cannot be used. Using the lithium aluminum hydride, you'll use your diethyl ether and water, so you'll use a 1-2 step again, and you'll make a primary alcohol. So here's our acid group right here, and then of course your alcohol will come here. Just like before, your hydrogen is going to go to the carbonyl carbon, and then your oxygen is going to pick up the hydrogen from the water. So this just shows you again a specific example. Now if I want to prepare alcohols from epoxides, the only epoxide that we're going to use is our